In the 2004 Indian Ocean tsunami, I happened to be working and living in Bangkok at the time. It had very short lead times to provide warnings to populations that might be able to avoid the consequences of that tsunami. There were many, many more activities that could have been undertaken that would have meant that so many people need not have died. The UNISDR was created by countries to try and assist principally governments initially, but increasingly, as we've observed over the last 20 years or so, the main actors that fundamentally decide how risk is created, reduced, or even prevented. For decades, the prevailing view has been that disasters are essentially acts of God about which we can do very little. What the data and the models and analysis that underpinned this tried to show was that this was false, that disasters were a function of human activity. We move conceptually from managing disasters, which traditionally is done in a reactive manner, emergency services, etc., to managing risk, which is done in a proactive manner. Understanding how we behave affects the creation of risk.
UNISDR is the guardian of the Sendai Framework for Disaster Risk Reduction. The Sendai Framework is an international agreement that the governments adopted in 2015 to prevent creation of new disaster risk, reduce the existing risk to ensure that we have sustainable development and we are able to protect the planet and the people. We conducted what we call a data readiness review. Countries were assessing how well are they prepared to monitor and report on progress, because it revealed a lot of data gaps. We had 87 countries who decided to participate in the data readiness review. Only 34 actually had access to all information, including the disaster loss data. Earth observation data contributes to our overall understanding of the disaster risk. And understanding that disaster risk actually then contributes to the better planning and policy making. If countries are not able to have the data and to monitor progress, it's very difficult for them to make also right type of decisions to reduce disaster risk in the future.
The burst of a tailing dam of one of the big mining companies in Minas Gerais basically took all 55 million cubic meters of mud all the way to the Atlantic Ocean, 600 kilometers away.
It's considered the greatest social environmental impact in Brazil, one of the greatest disasters from mining all over the world. The priority of the mining industry is to optimize the profit. So if we don't have a public control on this kind of situation, we will have more and more disasters.
The situation in Brazil is actually something that can happen everywhere where open pit mining is taking place. The lack of maintenance of the physical state of the dam did actually, lead to this happening. Through Sendai, if you use the Sendai lens, is to see how this type of disasters can be preventable. So, and this is where geospatial and earth observation technology can help a lot, because you can very easily locate where are open pit mining taking place, and also where these type of dams have been built. You can of course send inspectors to check on the state of the infrastructure. Then they can take remedial action, do some mitigation, reinforce the walls. But you can even set up early warning systems, and when it happens, sound the alarms so that people can move to safe ground.
Mais preocupante, temos várias empresas, algo em torno de várias barragens, algo em torno de 30, onde os laudos indicam uma não estabilidade dessas barragens.
Tenho certeza que nós temos muitas barragens em Minas Gerais, algumas delas oriundas de empreendimentos falidos, em que ninguém está tomando conta.
What really comes out of this disaster was that the population were not aware of the risk. And there's a key need from this disaster to work with the private sector to build resilient infrastructure, resilient solutions.
A lot of challenges actually related to the fact that we don't have the information available and the data available. This is a major challenge for the global community overall, and we play our role and want to advocate with others to make sure that we have access to the relevant data.
We've developed this product called the GAR for Tangible Earth 2017 update. Here what we're seeing are earthquakes and seismic activity. The yellow dots are representing earthquake events of an order of magnitude on the Richter scale of 5, and here where you see some of the red dots, these are a greater than 5 event. The real-time function allows you to switch between hazards, and here if we go from earthquakes to cyclones, we can see that this is now tracking a cyclonic event going through the Pacific, and this another one going across the Caribbean region. These events could be across all different hazards to a particular country.
GEO, for example, is one great example of doing that, and GEO is doing a really important work on increasing the awareness of countries to understand that the Earth observation data actually is openly accessible and freely available, and can be a really important source for making decisions that protect lives, that strengthen resilience and reduce disaster risk. All these tools and reports are, of course, openly accessible. We have UNISDR website, we have the prevention web that UNISDR is maintaining since many years, which really is a source for a lot of information to the global community on disaster risk and how to reduce that. If we look at the 20-30 years to come, there will be about as much critical infrastructure that will be built over these coming decades than already exists globally. Now we have a golden opportunity to make sure that that critical infrastructure is built in a way that is disaster resilient and actually reduces disaster risk and protects people and livelihoods and infrastructure instead of contributing to further risk.